Good morning and welcome to AP Stats for Wednesday, May 20th. Today I'm going to go over the prompt from this year's sample that they gave us. All right. Basically, they gave you an output of corn growth and bushels of corn harvested, whether it's genetically modified or whether it was regular. They also found the mean, the deviation, the sample size, the 5-number summary, and the differences. A simply says, explain why the yields from one type of corn are not independent of the yields from the other type of corn. It says pretty clearly that they took plots of land, 33 of them, and they randomly split those plots of land into two parts, and then they planted either the GM corn or the regular corn in each plot. They're not independent because they're in the same plot of land exposed to the same circumstances, the same soil quality, the same sun and rain and any kind of exposure issues. So it's logical to think that what impacts one half of the plot would impact the other half of the plot, so they're not independent from one another. B, based on the summary statistics, would it be more likely to obtain a yield of 123 or more bushels per acre from a plot of GM corn or a plot of regular corn? Justify your answer. This is not asking for you to give me an opinion. It's asking for you to justify your answer with the statistics. We have everything we need. Find the z-scores for how unusual a harvest of 123 bushels would be for GM corn versus regular corn, and we'll find the area. First thing I want you to do is verify the conditions. Now, again, I'm going to say this, but you should write it down as well. How do we do any of this? We have to normalize a distribution. It's a sampling distribution, so is it normalized? Well, let's see. Do we have random sampling? It says it is randomly dividing the plots to see which half gets GM, which half gets the regular corn. Do we have the 10% rule being observed? It's logical to feel like there are at least 10 times as many plots of land available for planting in the world. Specifically, the sample size for normality. Is the population normally distributed? Who knows? Is our sample size at least 30? Yeah, it's 33. So we can use normalized distributions here. All right, cool. So I want to find the z-score for the GM corn. That grows at 123 bushels minus the GM corn's mean of 125.018 over the standard deviation of the GM corn, 13.623, over the square root of the sample size, 33. So the GM corn has a negative 0.851 z-score for growth of 123 bushels. Now that's less than even the expected average. So when I'm looking for the probability of finding at least 123 bushels, it's going to be a large area. Since we're there, we might as well do it now. Normal CDF from negative 0.851 as a z-score to an infinite bound. Again, we're looking for 123 or more bushels, so it's going to the right. And that's a large area. That's 80.26%. So there's an 80.26% chance of getting a harvest of at least 123 bushels of the GM corn. Okay, well, we also want to compare it against the regular corn. So it's the z-score for 123 minus its mean of 120.4, was it 82? Can't even read my own writing. I think it's 0.482, maybe it's 0.402, who knows? Over the deviation, 10.321, over the square root of its sample size, 33. That's a z-score of 1.4015. Understand 123 bushels is more than the expected yield of the regular corn. So we're going to get a smaller area above it. And normal CDF from 1.4015 to the infinite bound is actually quite a lot smaller than the previous. It's 8.05%. So whereas there's an 80.25% chance of getting at least 123 bushels of corn from the GM corn, there's only a 8.20% chance of getting at least that much corn from the regular crop. That is overwhelming evidence that it's much more likely to get a higher yield of corn from the GM corn. Okay, dot plot of differences was shown. Describe the difference distribution. We're looking for GSOCs again. So GSOCs, are there any gaps or clusters? It's hard to tell gaps really with a box plot. And don't say there's a gap between 15 and 20. That's not a gap. This is a modified box plot, so there really is no gap at all. It's just that 20 is an outlier. So I go with the clusters. 25% of your data is contained in a difference between -2 and -1 bushels. So it's a pretty dense quarter right there. The rest are widespread. So GS for shape, it's a pretty strong right skew. We can see that there's a strong right skew. You could say the median, it's about 3, has about 5 bushels below it, so 3 to -2. But there's like 17 bushels above it, 3 to 20. So there's a large right upper half with a compacted left half, lower half. It's right skew. Moving on to our outliers. It's showing you there's an outlier of 20. It's not a surprise. But if you want to actually show some evidence, use the 1.5 times IQR rule above Q3. So 1.5 times 6 minus -0.9 plus 6 is 16.35, making 20, or 20.1, a very clear outlier. Center. Well, the mean is a difference of about 4.5 bushels, and the median is a difference of about 3 bushels, which is a much better measure because of the skewness and outlier. So really, I'd say the best measure of center here is the median of 3 bushels. And the spread, there's a 22 bushel spread between the low and the high. There you go, 22.2. Okay, now turn it over and it gives you hypothesis statements. It says the difference is 0, that's our null, not 0 is our alternate, and one of the conditions for inference that was met is the sample size being greater than 30, explain why it's necessary. We don't know at all the population distribution shape. We don't know it's normal or not, so we can't rely on that. If we didn't know it was at least 30, we'd have to have no strong skew or outlier in our sample. But we already just finished saying that there was strong skew and an outlier in our sample. So we would not have been able to normalize if the sample size had been under 30. And E, the test result gave you a p-value 0.0003. Based on that, what conclusion should you make? This is very strong evidence to reject the null, that there is no difference at any alpha level. We have evidentiary support that there is a significant difference in the yield between corn that is genetically modified and corn that is not. There you go. If this is similar to your exam on Friday, this is going to be a good exam. If I had to guess, if you put your all into this, I would guess that you might have had an error with part A. Why should we presume they're independent? My guess is you might have made some random guesses, some random stabs at it without any kind of support. But I hope that at this point, B, C, D, E, they shouldn't be hard. Just explain yourself carefully. All right. Obviously, there's no homework. We're done with homework for the time being. What I want you to do is prepare everything you need to do well on this test on Friday. So gather your materials, make some cheat sheets. You're allowed to. They're not really cheating at all. They're allowed cheat sheets. Print your formula sheet, print the inference guideline if it helps you. Write down the formulas you'll need so you're not rifling through papers when you're faced with this kind of question. It's not hard to do. Gather your materials and be ready. Tomorrow, Thursday at 10 a.m., I've scheduled a Google Meets call, which you got the invitation for already. If you want to join me, please do. If you don't, it's fine. You don't have to. I would ask that when we start the call, that if you're not in a quiet space, you mute yourself unless you have a question. Try not to make extraneous noise. Obviously, if you've been on one of these before, you know that it comes right up and it's distracting. They want you to turn your cameras off, so turn your cameras off. But just make sure that when you want to ask me a question, you unmute yourself. Otherwise, try to stay as quiet as possible. And ask whatever you want. All right, if I have the answer, I'll tell you. If I don't know the answer, I'll tell you that too. Okay? That's all I have for today. Prepare your materials and get a good night's sleep.